Hello friends, in my today's video, I will be teaching you guys what is machine and mechanical energy. So we will be learning about different types of machines and we will be learning something about mechanical energy. Okay? So off to this and let me share something to you. I okay. Let me share something with you. I want to share my slideshow with you. Please tell, is the slideshow visible to me? If it is not, please tell that if is the slide visible to me. Sorry, is the slideshow visible to all of you? Please tell me. Please let me know. Okay, I have started this. Okay, so now we will be learning about machines and mechanical energy. So welcome to my session. And today, okay, now is it visible? Now is my screen visible to you? Now is my screen visible to you? Kanak, now is my screen visible to you? Hi, Siddhi. Okay, so now we will start with welcome all of you. Welcome to my online session. It's 15th November, part 2, machines and mechanical energy. Okay, so we will start with what is a machine. Okay, we will start what is a machine till the time you tell me what is a machine. Okay, I can see only two participants now. So from Kanti, you tell me what is mechanical energy. No, not mechanical energy. Please tell me what is machines. Okay, I want to know what do you know about machines. Oh, sorry, I was not. I didn't unmute. I didn't unmute. I'm very sorry. I'm very sorry. So I want to. Okay. The Siddhi, the question was. Yeah. Okay. Okay, Kanak. And now I've unmuted. The question was, what is a machine? So I was telling you what is a machine, and I I muted myself accidentally. So, no problems. We will start. What is a machine? So, now I am telling you what is a machine. Is the screen visible to all of you? Is my screen visible to all of you? Yeah. Okay. A machine is a device. It is a device that helps in doing a certain task and it makes our work easy. It also magnifies the force. So, what does it mean by magnifying the force? Magnifying the force mean that if we apply smaller force, we can have an example of a nutcracker. I apply a very small amount of force and it is enlarging the force. Means magnifying means to make it large. It is making the force large and it is making the making me capable of cutting a nut cutting a nut. Okay, cracking a nut. Okay, not cutting, cracking a nut. Okay, so this is the meaning, and it also helps us gain speed. You will learn it also helps us to gain speed once you know about mechanical advantage. Okay, once you know about mechanical advantage, you will, okay, device which overcomes resistance. Yes, this is also correct definition, but I thought to take it a simple one. Okay, that helps in doing our work, and it also uh, overcomes the resistance. Okay, so we have many types of machines. So one of the type of a machine is lever, a pulley, a wheel and axle, inclined plane, screw, and a wedge also. Okay, a lever. Can you see this? This is an like, I wanted to show you this. This is a diagram of a crowbar. Okay, so here we will apply some effort, and this would be our load, and this would be the fulcrum. So a lever is a rigid body capable of moving on a fixed point. Okay, so what is a fixed point? Okay, what do I mean by rigid body? Can anyone tell me that what do I mean by a rigid body? Okay, can any one of you tell me? Am I not audible? Not I'm ask Siddhi, I'm not asking about a point that on which a machine or a lever rotates. I'm asking that what is the meaning of rigid body? What do I mean by rigid body? Okay, I'm not getting any answers. So may I speak? Shall I? Okay. A rigid body is a body that doesn't changes its. Okay, I'm sharing my screen and will tell you. Okay. Not able to bend. Oh, who said this answer? Okay, Siddhi. I want to show this to you. Okay, yeah. Not able to bend. Siddhi, I have broadcasted this to you. Okay, not able to bend. It's not like that. I have not. It's a body that doesn't change its shape easily. Okay, so it's also a type of. Not able to bend is also a type of an answer, but I don't see that clarity in that. Okay, okay, so we have the definition of the parts of lever, and we have parts of lever. So one is fulcrum. Fulcrum is the part of lever on which it rotates. And effort is a point on which we apply force on the lever, and load is a resistance on a lever or any machine. So let's see to the definitions. So the point about which a lever rotates about a fixed point. Okay, the point about which a lever rotates. Okay, it this thing has been added. Okay, so I want to about a fix about rotates. Okay, so the point on a lever where we apply force, and load is a resistance offered by a machine. Resistance means like the friction that is offered by a machine. So we have many types of lever: class 1 lever, class 2 lever, and class 3 lever. So we will know about the various classes of lever in this. Okay, you're not audible, not able to bend. Okay, now I want to hide. Okay, so gosh, Siddhi, you tell me, am I audible to all of you, or is my screen visible to you? Okay, so now we will start. Class 1 lever. In this class 1 lever, the fulcrum lies in the middle, and the load and effort can be on the either sides. Okay, so this fulcrum is in the middle. With respect to which lies in the middle, with respect to which part of the lever lies in the middle, we have three classes of lever. Okay, so one is a class 1 lever. Class 1 lever, we have fulcrum in the middle. So the point on which the lever rotates is in the middle in class 1 lever only. And other two parts, the resistance and the effort. So the example of class 1 lever is crowbar and scissors. Okay, crowbar and scissors are example of class 1 lever. See, this is the effort. I told you scissors is an example of a class 1 lever. I told you, right? Yeah, audible. Okay. So effort. Okay. So this is the point where we apply effort on when we want to get the work done by the scissor. This is a point where the uh, scissor rotate, and this is a resistance. What is a resistance? Okay, resistance होता है जो काम करने में थोड़ा डिफिकल्टी ऑफर करता है. ओके, सो रेजिस्टेंस इन हिंदी से जहां पर ऑब्जेक्ट रेजिस्टेंस ऑफर्ड बाय द लीवर को हम एक उसमें कह सकते हैं ऑब्जेक्ट जिस पर हमारे को काम करना होता है, उसको भी हम लोड कहते हैं. ओके, सो उसकी डेफिनेशन में लवली एक्सप्लेनेशन. Okay, wash hands. Okay, I will wash hands. So now we okay, लोड जिस ऑब्जेक्ट पे हमारे को काम करना होता है उसको हम लोड भी कहते हैं. तो यहाँ पर आपको जैसे पेपर रखना होगा तो आप यहाँ पेपर भी रख सकते हो. ओके, got it. Now we have class 2 lever. So class 2 lever में होता है load is in the center and the fulcrum and effort. इसमें अब होता है load. आप FLE से भी लर्न कर सकते हो. FLE मतलब क्लास 1 लीवर में फल्क्रम सेंटर में होता है, क्लास 2 लीवर में लोड सेंटर में, और क्लास 3 लीवर में एफर्ट सेंटर में. तो अब हमें पढ़ते हैं इन दिस टाइप ऑफ लीवर द लोड इज इन द सेंटर एंड द फल्क्रम एंड एफर्ट कोई सी भी साइड में हो सकते हैं. तो एग्जांपल है इसका नट क्रैकर और बॉटल ओपनर. आप उसकी इमेजेस इसमें अभी मैं प्रेजेंटेशन में आपको दिखाऊंगी. ओके, सो नाउ वी हैव, इसमें लोड बीच में है, फल्क्रम और एफर्ट कौन से, हम एफर्ट और फोर्स बोलते हैं. ओके, सो अब देखिए ये नट क्रैकर, इट्स अ नट क्रैकर. तो ये एफर्ट है, लोड बीच में है. ओके, जिस ऑब्जेक्ट पे हम काम करेंगे वो बीच में रखेगा, और ये फल्क्रम है जिसपे वो रोटेट करेगा. गॉट इट? Please tell me. It's not wash hand, it's symbol of clapping. Okay, Siddhi. Wash hands. Okay. I want to know that is everything like, am I clear to all of you? Have you got it? Please tell me. Have you got what I said? Okay, Kanak. Okay, I'm sharing my screen again. Okay, so let me expand it. Okay, now this. Okay, so this is the load. Okay, so nutcracker, this is an example of nutcracker, as you all know. Now we come to class 3 levers. Class 3 lever, a lever in which effort is in the center, and class 3 lever is in which the effort is in the center and load and fulcrum are on either side. वो किसी भी साइड में हो सकते हैं. फॉर एग्जाम्पल ह्यूमन फोराम. आपका एक फोराम होता है ना, ह्यूमन का फोराम, जो पार्ट आपके सबसे लाइक from your biggest finger to your elbow, it's called the forearm. So उसका जो पार्ट है उसमें जो सेंटर में होता है वो एफर्ट होता है, जो एल्बो है इट्स फल्क्रम, एंड जहां आप पकड़ते हो इट्स द लोड. ओके, am I audible? You are perfectly clear. Thank you, Siddhi. Thank you. Okay, now let's move on to okay, and tongs and tweezers. Do you know pair of tongs are used to lift ice, and tweezers, your mama must be saying chimta. She must be, if we has any one of you made chapati at home? Please tell me, any one of you at home? Okay. Please tell, has any one of you made chapati at home? Okay. Uh, I think the question, I think I'm not audible. Okay. So when we make chapati, and this is not a tweezer. Okay. This is an example of class 3 lever. Okay, got it? Now we have an example. Now we have pulley. Pulley. So I will not show you any definition of pulley. This is an effort. So I want to tell you something. Pulley works on the principle of a wheel and axle. Okay, so see, this is the wheel moving about. This wheel is fixed. That is why it is classified as a pulley. Okay, so we have moving pulleys also, and this is the effort. This is the fixed point, and this is the load of the machine. Okay, every machine may have an effort or a load. Got it? So a pulley is a type of a class two class. Sorry, it's not a lever. A pulley is a type of a wheel and axle, and it is used to lift objects. And do you know, it helps us to lift an object in a very suitable direction. Okay, can you please repeat? Not me, but have seen mom. But have seen. Okay, Siddhi, you haven't made it. Okay, can you please repeat? Yeah, Kanak, I shall repeat for you. Please tell me from which point you have left, so that I can get to know that from which point I have to read. Okay, please let me know. Okay, okay, okay. Um. So now we come to Kanak, please tell me from which point have you left? Okay. Till the time she is telling me, I am explaining you again that pulley is a kind of wheel and axle arrangement, a fixed wheel and axle arrangement, and it is used to lift objects. And do you know, if we are using one pulley, only one pulley to lift any object, we would not have, if you would find a mechanical advantage is that I was saying that the question of chapati one. Okay, so I asked that, have you ever made chapati at your home? So you must have seen these chimta type of something. It's a machine and it's type of that. Have you ever made chapati? Yeah. Yeah, I asked this question only. From that point, okay, from that point, I have to repeat. From that point, I was on this. Kanak, I was on this diagram on this image of tweezers and this one, and I wanted to tell you that it's a type of a class 3 lever where you apply your effort here. This is a fulcrum because it is a point on which it rotates, and this is, and there will come the object load, we say. Okay, so now we come to pulley. Has have Okay, pulley. From pulley, okay, pulley is a machine. A pulley is a machine that works on the principle of wheel and axle arrangement. Okay, it works on the principle of wheel and axle arrangement. It is used to lift objects in short. Okay, now we come to wheel and axle arrangement. A wheel and axle arrangement has the following properties. In this arrangement, wheel should always be bigger than axle. If the wheel is not bigger than the axle, so what is the you can have a simple ball bearing. Then what is the need of this wheel and axle arrangement then? Okay, just wanted to repeat the question. Okay, you just wanted me to repeat the question. I asked that, have you ever made chapati with your chapati at home? That was only the question. I thought that you were asking me to repeat from that point. Okay, so it doesn't I it doesn't like. Okay, okay, so a wheel and axle arrangement has in this arrangement, wheel should always be bigger than the axle, and we have an example of steering wheel and screwdriver. See this steering wheel, and screwdriver is also a type of a wheel and axle. This is regarded as wheel, and this is regarded as the axle. Okay, a screwdriver. Okay, what is a screwdriver? You may want to ask. It a pechkas. In Hindi, we say it as pechkas. Okay, have you got it? Have you got what I said, Kanak and Siddhi? Am I audible to you? Because I'm not getting the answer. Okay, so now we come to wedge. A wedge is a type of a machine that is thick at one end and is thin at one end, and that thin portion is very sharp. It wedge. Examples of wedge is knife and a blade. Okay, so and it is made of two inclined plane. Though inclined plane doesn't satisfies the uh, definition of a machine, that it overcomes the resistance offered by a machine, but still it helps us. Okay, but still it helps us. Okay, and do you know this wedge is made up of two inclined planes and screw, and now we have this screw. Do you know what do we call screw in Hindi? It is called page. And just now only I gave you an example of page cast. Dear Simran, actually I had urgently leave the session, so will you please continue later, or I will miss it, which I don't want to. Start, uh, Siddhi, I cannot stop it. I cannot stop the session right now. You can watch the replay, okay? And I may end it very soon, okay? So please wait for a while. It can be ended very soon, okay? Now, okay, screw. So to know the principle of screw, you just wrap a paper around a pencil, and that sliding part of the pencil will act as grooves, and the force that you apply here, that you apply on the tip, is transmitted to the grooves, and then it is, and thus it is magnified. Okay, okay, so now we have screw jacks. Screw jacks also works on the principle of a screw, and it it's the point where we screw jacks is used to lift cars when they are punctured. Okay, okay, screw jacks. So you will apply the force here. You will move it around, and then it will up, and it would be the condition of car, and when you will apply, it would be like this. Okay, got this? Okay, got this? Okay, so now we screw jacks got. Have you got the principle of the screw jacks? Okay, so now we have mechanical advantage. A smaller effort can help us to move a much greater distance. Okay, and do you know? So mechanical advantage of a machine is that when we apply a smaller force, and it is helping us doing a very big task. So that is the advantage of a machine. It is a machine will either multiply force, or it will either multiply speed. So we will learn when will the machine multiply speed and when not. Okay, Siddhi, I was muted. I suddenly I was accidentally muted. I didn't know how I was muted, but I got muted. The formula of finding mechanical advantage is load upon effort or effort arm upon load arm. Okay, why do we take it as effort arm upon load arm? क्योंकि effort arm जब fulcrum, अब we will take an example of class 1. Now we come to levers. Okay, so the mechanical advantage of levers. Now am I audible? Please tell, now am I audible? The formula of finding mechanical advantage is load upon effort or effort arm upon load arm. So effort arm, so why have we taken it as effort arm upon load arm and load upon effort? So we have taken it as effort arm and upon load arm because when the effort arm is greater, do you know, it multiplies force, and load arm is bigger, it multiplies speed. Okay, you can take an example of two scissors. We have two examples of scissors. You take that lamba one in which the load arm is the bigger from the fulcrum, and you take the example of chota one in which the effort arm is lamba, and you will get to that in lamba one, in the taller one, the speed would be faster, and in the chota and in the smaller one, the force would be lesser. Okay, so that is the point. Okay, so now I have a numerical for you. A seesaw of length 4 meter is supported at its center. A board weighing 4 Newton sits at a distance of 1 meter from the center. 1 meter, where should a girl of 2 Newton sit from the center? Okay, where should the girl of 2 Newton? Can you please tell about the chota and bada you are talking about? Okay, so okay, I was telling when the I have noticed and I have studied somewhere that when the effort arm is bigger, okay, is taller or bigger, you say, the force is multiplied. You would get to apply lesser force, and uh, when the load arm is bigger, you would get to apply more force, but the speed of doing an action would become the speed would gain and height. Okay, so I have a numerical for all of you, and now I have the solution to this numerical, and then we will end up this session. So effort arm into effort is equals to load arm into load arm. Effort is equals to 4 Newton. We take the weight of the boy as effort, and load and and the weight of the girl as load. So 4 Newton into 1 meter, 2 Newton into x meter. Okay, so forming a simple equation, we cancel out 2 Newton by Newton. Okay, we cancel out Newton, 2 into 1 meter, 2 Newton and Newton, the units are cancelled because there here is also Newton and here is also Newton, so the units are cancelled, and then 2 goes to 1 by 2. Okay, 2 into 2 is equals to 2 into 2 is equals to 4. So 2 meter, not centimeter, but 2 cent. So a girl would sit 2 meter from the center. Okay, got it? Have you got it? Please tell me, have you got it? Okay, repeating it again, 4 Newton into 1 meter. So we will take as effort into effort arm and load into load up upon load into load arm. So effort, 4 newton is the effort. Okay, so 2 newton into 1 meter, and we don't know about this one, so we take it as it is, 2 newton. So we cancel out 1 upon 2, newton to newton, and 1 and 2 goes to 2 by 2, to 4 by 2. Okay, 2 goes to 4 by 2, so 2 into 1 meter is goes to 2 meter from the center. Have you got it? Oh, absolutely. Good vibes. Thank you. Thank you, dear Siddhi. Now I come to the end of my session. And if you want these videos like weekly, so please give me a thumbs up to this video, and please share your comments in the comment section. Bye bye. Bye bye. And please multiply. I told you how to multiply this speed and force. You multiply my subscribers. Bye. You share it with your friends if you liked it. Bye bye.